Welcome back everyone to part 4 of our Unreal Engine 5 tutorial series on Smart Enemy AI. In this part we'll be covering the EQS, or the Environment Query System, and we're going to be creating functionality for the enemy like this that allows the enemy to strafe around the player in a certain radius. And then after a while the enemy will go attack the player and then go back to strafing. And I'll also be showing you how to create functionality like this, where the enemy goes to hide behind cover, waits a few seconds, comes out to attack the player, and then goes to hide again. And we'll be using the Environment Query System to implement all this functionality, which allows the enemy to understand the environment around them and behave in a more smart way and position themselves in a smart way. So let's get started. So this is where we left off last time. We have this enemy that patrols. I can make a sound. The enemy hears the sound. The enemy sees me and starts attacking. But the attacking state is quite boring. The enemy is just constantly attacking, not moving. And if I run away, the enemy just chases me and starts attacking again. So we're going to make this state a bit more interesting by making the enemy strafe around the player. And we're going to be using the EQS, or the Environment Query System, to get the strafe location. So let's see how we can do that. But before we jump into the EQS, there are just some animations that I set up already, and I'm going to go over it real quick, but I'm not going to show you how to create them, of course, because it's an AI tutorial, not an animations tutorial. But I did create this blend space, which is just basically 4 different animations that we're going to be using for strafing. So move forward, move left, move back, and move right. And there's an idle animation as well. And a blend space is just a single animation that blends between multiple different animations depending on 2 things. And here 2 things are the direction on the x-axis and the speed on the y-axis. And of course, as always, I'm going to leave all of the animations, source code, full project files for free to download for all of my patrons, and link down in the description. Also, I modified the animation blueprint for Manny to get the direction. So now we set the direction, which again we need to decide where the blend space is going to play, or which animation the blend space we're playing. And the direction, we're just getting it based on calculate direction node, which takes a velocity and an actor rotation. But also, we won't always be in this strafe animation. If the enemy is chasing me, I want them to do the regular run animation, which comes with the blueprint, with the character by default, the mannequin, and it's this blend space. So we need to be able to choose between different animations based on whether we're currently focusing on a target and attacking them, or we're just running around. So to do that, I created a new variable here called isFocusingTarget. By the way, this is all in the event graph of the animation blueprint. And this isFocusingTarget variable just gets the actor, the AI controller of that actor, and checks if we have a focus actor that is valid. And if so, then we set isFocusingTarget to true. And then over here in our anim graph, in our locomotion state, we have an idle and a walk run. In an idle, I do a blend pose by bool, which chooses between 2 different animations depending on a Boolean variable, which is isFocusingTarget here. So if we are currently focusing a target, we're going to use this sword idle animation, if we're idle, of course. And if we're not focusing a target, we're going to use the regular idle animation. And back here, I did the same for walk run. If we're focusing a target, blend pose by bool and choose our sword strafe blend space. And I just pass the direction and speed to this blend space. And if it's false, we default to whatever we already had here, which is our walk run blend space. And this only takes speed because it's a one-dimensional blend space, not 2D like our strafe one, which is a bit more complex. All right, so that is it for the animation setup. So now let's jump directly to the EQS system. Opening up our content browser in our enemies AI folder, let's create a new folder here and call it EQS. And inside EQS, search for environment query. And we're going to call this EQS underscore strafe. Great. So we open it up here. And what is an environment query? An environment query really is a query that the enemy AI or the actor does that returns one point or a set of points from the environment around them based on certain criteria that we set. So for example, if you pull off of here, it looks a bit similar to the behavior tree, you'll see a lot of generators. We're only focused on generating points around the actor. So either you generate a circle, you generate a cone, you generate a grid, and so on. So just choose, well, let's just choose grid for now and show you how it looks like. And over here is the details of the grid. Now we're generating a grid of points where the half size is 500 and the space between each point is 100. So how do you actually visualize this in the world? To do that, we're going to create something else called a testing pawn. So right click, create a blueprint class and search for EQS testing pawn. And just create this one, call it EQS underscore testing pawn, and drag and drop this into your level. Now, this EQS testing pawn, if I go to the details panel here, I can search for EQS, and you have something called the query template. And this is just the EQS underscore strafe that we just created. Now, if I select this one, you see the grid of points that I was talking about. Let me open both of them up next to each other here. So now, if I play around with this grid half size, let's say I can make it 1,000. Then here we have a grid of 1,000 points. I can say the space between each point is 200 and so on. Now just note that the more points you have, the more expensive of an operation on your processor or GPU this will be. So make sure that you're using it wisely, basically. But if you do this query like once every few seconds, it's fine. But if you're running the same query over and over again per tick or something, then yeah, you really don't want to have a lot of points here. But so far, these points don't mean anything without some tests. Now, these points are just all possible locations that the enemy can move to. But for example, if I move into this block here, the enemy can't really reach inside this block. So you may want to say, I want to filter out things that the enemy can't reach. So right click here and add a test. There's something called a pathfinding test. And by default, if you don't change anything on the details here, pathfinding will discard anything that's unreachable. And you can see here in the description, it says that. So if I go here, these are blue now and have a score of 0. It means that the EQS will never choose these locations. And everything outside is green and have a score of 1. It means they're all scored equally the same. Now, when we run the environment query, we can say, give me the item with the highest score, and that's the item that I want to go to. So what other tests can we add to an EQS? Now, if I right-click here and add test, there is something called a distance test. So I can say I only want points that are close to me, for example. So in the distance test, there is a range here. So we're going to say range, and we're going to say, I want you to filter out everything that has a maximum value of 500. So now we're only choosing points within 500. And the closer they are to 500, the higher the score will be. So this 2 is the highest score, 1 is lower score, and so on. So the closer they are to our maximum range, the better this query will score them. Now we can say also, I want there to be a minimum value of 100. So it filters out anything that's 100 or less. So then 200 as well, we'll filter out some more, 300, and so on. And this is basically how you use the EQS. You just add a bunch of tests and it will return a location, and then you tell the enemy or whatever the AI to move to that location. Nice. Let's delete all of this because that was just for tests. And let's think what we want to use for strafing. Now, strafing is just moving in a circle around a target. But so far, we've been generating grids. So we probably want to generate a circle like this. And yeah, this is a very large strafe radius. So maybe you want it to be a smaller circle. like say 350. And let's use only 5 points on the circle. So change number of points here to 5 and change the spacing method to be by number of points. Now these are all the possible locations that the enemy can move around the player. But right now, if you look at circle center, we're generating it around something called Environment Query Context Querier. Now, if you select this dropdown, you only have two things, a querier and an item. And a querier is basically the actor that's running this query. So we're saying generate this circle around the actor that's running this query. But the actor is the enemy AI, and we don't want to generate the circle around the AI. We actually want to generate the circle around the player itself. So how do we get something here that references the player or the target we're attacking? Now for that, we have to, let me put this back here, go back to our EQS folder, and we're going to create something called, create a blueprint class and search for contexts. And click on Environment Query Context Blueprint Base. And we're going to call this EQS underscore context underscore attack target. Now open this up, and what we want here is over on the functions, override a function called provide single actor. Click this one, and here we want to return the attack target that the enemy is currently attacking. Now we don't really, well, what we have here available to us is the actor that's running the query, but we don't know who are they attacking. So let's actually create the variable for that. And we're going to do it in our AI controller. So open up your AIC underscore enemy base, which if you recall was an AI controller right here, AIC enemy base. And we know who we're attacking when we switch to the attacking state. So we have a function called set state as attacking here, and that takes an attack target. Now all we're going to do is promote this to a variable. So right click, promote to variable, and I'm going to call it attack target. And just put it here. Great. Now compile and save, and back in our EQS context attack target, let's get our actor, pull off of it and search for get AI controller. And we're going to cast this to our AIC enemy base. And we are going to get our attack target. Nice. Compile and save. Now in our EQS strafe, we can generate the circle instead of around ourselves or around the enemy. Now we can generate it around whoever the enemy is attacking. But we have one slight problem. In our editor, before we actually play, we can't test this because the pawn is not attacking anything. We don't have an attack target. So I'm going to create something in our EQS context attack target just for testing purposes. We're going to set this player start as our attack target. So go over here, search for get actor of class, search for player start. And yeah, just copy and paste this, and this is what we're going to return. And before doing this, just add a print statement to make it very clear that this is for testing only. Testing purposes only. And we're going to plug this here. Let's also actually comment this. So I'm going to highlight them, press C, and say for testing only, so that we don't forget and play with this. All right, so now if I go here and just move my pawn around, now we're generating the circle around our player instead of around ourselves. Perfect. This is what we want. But let's also quickly add a test here. So right click, add our pathfinding test to make sure that we're generating points that are actually reachable, and leave everything as default here. So now all the points have an equal score of 1. Now let's test this out really quick. What we want to do is run our EQS in our behavior tree, get a valid location, and tell the enemy AI to move to that location. So let's open up our BT enemy base, our behavior tree, and let me show you how we can run an EQS. Now, over here in our chase player, I'm just going to move this away for now and and remove the arrow and I'm going to create a new sequence here in its place. And I'm going to call it Strafe. Now, over here we want to run our EQS. So you can do this in two ways. You can create a custom task and run an EQS in there. And to do that, let me just open a custom task and show you. You can right-click here and say Run EQS Query, choose your query template, assign on query finished, and then get results as locations, and you get a location from here. Now, I'm not going to do all of that, so I'm just going to delete it. I just wanted to show you how you can do it in a task. But we can do it in a much simpler way because we're not doing anything complex yet. With the built-in task that's called Run EQS Query. Now this EQS query on the details panel here takes your Strafe environment query and has a run mode. Run mode, this means what should it return? Should it return the single best item from all the locations? Should it return an item from a random best 5% or an item from the random best 25%? For now, I'm just going to choose random item from the best 25%. Then it has a blackboard key here. This means that the location that this environment query will return, where should it be stored on the blackboard? Now, since the location is a vector, we need to store it in a vector blackboard key, and the one we have for that is point of interest. So we're just going to select that. So after running this query, it will return a vector and store it in point of interest. So I'm just going to tell the AI to move to our point of interest. Simple as that. Let's also increase the acceptance radius a bit to 10 just to remove any flakiness. And before running the query, of course, we want to set the movement speed to walking. And also let's focus our target, our attack target. And that will be our strafe sequence for now, but let's see how this looks like. So on to our first test. Never forget to return this to the correct pin when you're done testing in the editor. And let's move this pawn away for now. Let's bring our enemy closer to us. And let's remove the patrol point from the enemy so they don't go running away from us to patrol. All right, now if I play, the enemy sees me and starts strafing around me. Now to test this, press the apostrophe key and press 3 for EQS. On the top left it says 3. Now you can see the points that the enemy chooses. So this is the winner, enemy's going to choose that. This is the winner, enemy's going to choose that. And enemy's strafing around. But you'll notice something. The enemy might pick a point we don't want them to pick. For example, the enemy now choosing this point over there, which means they move diagonally across me. I don't want them to do that. I don't want them ever to move diagonally like they're doing now. I want them to always move in the circle itself and not cross the circle. So let's add some tests to our EQS to prevent that from happening. Great. Back here in our testing pawn, let's just move it somewhere here. Our attack target, let's plug in the test player start again so that we can see it in the editor. And let's move our environment query somewhere here. All right. So with our attack pawn, with our testing pawn selected, we can see that all the points have a score of 1. That means that they're all equally as good of a point to move to than anyone else. But we don't want that. I want, if the pawn is standing here, that these 2 points, the one on the left and one on the right, have a higher score, so that the pawn will always move to these 2 points. So to do that, we're going to add a distance test. So right-click on your circle here and say Add Test Distance. So we're going to keep filter and score because we want to filter things that are outside of a certain range and also assign a score to things that are closer to the range we give. If you do filter only, it means that you're just removing things that are outside the range and keeping things that are without changing the score. And if you do score only, that means you're only assigning a score to them, but you aren't removing anything. But we want both filter and score. And we want the distance to the querier, so the distance to the enemy themselves, to have a range, a maximum range of whatever our circle radius is, or our circle diameter is. So if the radius is 300, let's say something around 500. So now you can see that we filtered out these blue ones with a score of 0, means they're filtered out. We filtered out anything that is further than 500 units away. So that means that the enemy will never go from here to here. They're only going to go to the next closest 2 circles, which is great. But you can also see that the one they're currently on is also highlighted and has a score. We never want them to stay in place. We don't want them to stay on the point they're currently on. So we're going to also add a minimum value, let's say of 100 or 150. So that means anything that is closer than 150 units to you, filter it out. Great. So now the enemy will, if the enemy is here, then the valid 2 points are this one and that one. And if the enemy is here, the valid 2 points are this one and that one, and so on. And if you recall, the run mode that I'm running is best 25%. So these two, randomly, the enemy is going to pick between them because they're in the 25%, of course. All right, so let's test this now and see that the enemy should not be moving diagonally anymore. Always remember to put this back. Very important. And let's move the pawn away. By the way, the enemy can see the pawn as a player and go attack it, so make sure the enemy does not see this pawn. And if I play, let's also open the EQS to test. Great. Now you'll see that the enemy is strafing around me and never choosing the point that they're currently on and never going diagonally across the circle anymore. Always moving in a circle. Perfect. That is exactly what we want. Now we can add something also here in the behavior tree. Say when you reach a point, I want you to wait on that point for, I don't know, like a 0.3 seconds with an 0.2 second random deviation. Random deviation just means plus or minus 0.2 seconds randomly. So either 0.5, 0.1, or anything in between, to give the enemy some sort of randomness in their movements. All right, so now they move. Wait for a random amount of time between 0.1 and 0.5, and then move to the next point. Excellent. Now let's have the enemy attack as well. So over here, we have our chase sequence, and we have our strafe sequence. Let me rename chase here just to attack, and strafe will be strafe. So we have a selector, right? And we were saying if is wielding swords. By the way, at some point I had the wielding sword here. I moved it here. It shouldn't matter, but it's good to have it on the sequence itself. Anyway, so we have if is wielding sword, that's what the enemy will do. And otherwise they will strafe. Now we want them to also attack at some point. So let's put the attack here. And right now, if we just keep everything as is, the enemy will just attack. They will never move to strafe because nothing causes the attack sequence to fail. So we want it to fail after some time. So which means we're going to add a cooldown to it. So right click, add decorator, and search for cooldown. And let's say something like 10 seconds. So click on this, cooldown time, 10 seconds. That means that the enemy can only attack once every 10 seconds, and if they're not attacking, they're going to be strafing. Nice. Okay, so let's see what this looks like. Go here, I play, enemy sees me, start strafing. Strafing, should keep doing that for 10 seconds, and then after 10 seconds, they should attack me and go back to strafing. Nice. Now, one thing we also want to do is that if the cooldown of the attack ends while the enemy is still moving to a new point, we want them to ignore. They're moving and go to attack right away. This means that if you click on the cooldown, go to Observer Aborts here and say lower priority. That means that once this node becomes ready, the cooldown is over, abort anything of lower priority, which means anything on the right. So abort strafing, basically. Nice. All right, so now there's one thing we want to fix, which is the giving the enemy different attack or defend radiuses. What do I mean by that? I mean that now when we play, the enemy, if I'm far away from the enemy, they're going to still be walking to reach me. And once they reach me, then they're going to continue strafing. And when they want to attack, they run at me. And we set the attack range to 150 units, if you remember back here. When we move to target, we have our acceptable radius of 150 because we want the enemy to be 150 meters away before they attack. And here, when we strafe, we don't actually tell the enemy when they are able to strafe. If I'm at the end of the map, they will still be strafing very slowly around me. So we actually want to tell them you can only strafe around the enemy, around the player, if you're within a certain range from them. And you can only attack the player if you're within a certain range from them as well. So to do that, we're going to create two new Blackboard keys. So go over here to your Blackboard and create a float key and then call this the attack radius. This is going to be the value 150, and we are going to have another float key here and call this the defend radius. This is the radius that the enemy can be circling the player in, which is sort of a defensive stance. So that's why I'm calling it defend radius, and this will be around 350 or whatever we set the radius of our circle to be. All right, so actually how do we get these values? So if you recall, we have an enemy AI interface, this BPI enemy AI, that has two functions, the patrol route and the movement speed. So we're going to add another function here and call this get ideal range. And it's going to return two values. One is the attack radius of type float, and the other is the defend radius of type float as well. Now, if you compile and save, recall that we are implementing this interface in our enemy class, our enemy actor. So if you go to enemy base, now you're going to open up interfaces on the left here, and you can start implementing this get ideal range. So let's say for now, for default, we're going to add the attack radius to 150. And the defend radius, whatever we had our circle here to like 350. Okay, let's do 350. All right, compile and save. Now we have our base enemy class that's setting these values, but we're not actually assigning them to our Blackboard keys. And we will do that over here in our enemy AI controller, our AIC underscore enemy base. So over here, somewhere on possess, let's get our Blackboard variable and say set value as float. And the key name is going to be the name of our attack radius and defend radius. So I'm going to right click, promote this to a variable and call it attack radius key name, like we did for all the other key names. And I am going to do this once more for the defend radius. So right click, promote the variable defend radius key name. All right. Now where are we going to actually get the values for these? Well, the AI controller knows about the pawn that they're currently possessing. So off of possessed pawn, just call our get ideal range function that we implemented in our interface. And this will be the attack radius and this will be the defend radius. Oh, and most importantly, don't forget to add the values of these key names. And they should be exactly as you've written them down in your Blackboard. So I'm going to copy and paste them to make sure I don't have any typos. The attack radius is called this, and the defend radius. Where's my blackboard? Yeah. And the defend radius is called like this. All right. So now we're getting the ideal range from the enemy class, and we're setting the blackboard variables that are corresponding to these values. Now we can actually start using in our behavior tree these two variables. So what we want to do here is tell the enemy if you are not within the strafe radius, then don't strafe. You have to actually go to it. And if you are within the strafe radius, then you're good. Then you should continue strafing. But there's one thing we have to do first to be able to check if we're in that radius or not. And that's create a decorator that checks, are we within a certain radius? So over here in decorators, create off of a BTD decorator blueprint base, put it in our decorators folder, and we'll call this BTD underscore is within ideal range. And as always, go to overrides and do perform conditional check AI, override this function. And what we want is to check, are we currently within the range that we're given or not? Whatever that ideal range is, whether that's the attack range or defend range or whatever we're given. So we want to add a input variable over here for our ideal range. And this is going to be of type blackboard key selector like we did before. And we are going to pull off of this and say get value as float, because we know that this is a float value. And now we want to check, is the distance from the pawn to their attack target less than this ideal range? And if so, we'll return true, and otherwise we will return false. So we have the controller, and the controller has an attack target. What was it? Oh, we first have to cast this to our enemy base controller and get our attack target from here. And we can call the get distance to function, which takes one actor and another target actor and returns a float value, which is the distance between them. Let me clean this up a bit here. Move this here. All right, now what we want to do is make sure that this distance is less than or equal this. So we can just do something like if this is less than or equal this value, then return true. But we also want to add a little bit of margin for error. So before checking if this is less than that value, let's actually subtract a number from it. And let's promote that to a local variable, because we only need it locally in this function, and call it error margin. And I'm just going to set this error margin to something like, I don't know, 50. Just to give us some room for error. Move this here. All right. And now we check if our distance minus the error margin is less than this value, then we are within the ideal range. Great. So back to our behavior tree. How do we actually use this? Well, if I move all of these to the side here, strafe now is a sequence node. I'm going to make it a selector instead. So I can actually move all of these here. I click Control and pull to move all of the connectors to it. And I'm going to name this strafe again. But the reason I'm making it a selector, oh, and of course, these should all be under a sequence. Whoop. Is because we're going to check something here. If we are within the ideal range, if we're not within the ideal range, then move to it. Otherwise, you can strafe. So we're going to add a decorator that we just created here, is within ideal range, and click on the defend radius as our ideal range. And make sure to inverse condition. We want to check if we're not in the ideal range. And if we're not in the ideal range, then what are we going to do? Let me move this to the side a bit. Then we're going to move to the ideal range. Now, so far, how we've been moving is calling this move to task. that takes a blackboard key, which is either the target they should move to or the location they should move to. And we manually set this acceptable radius, like we did here for move to the attack target and within 150. Oh, 150, yeah. But we don't want to do this anymore. We want to actually make this 150 a variable. So we're going to have to create our own custom move to task, which is quite simple. So again, over here in tasks, create one off of blueprint base, put it in our tasks folder, and call it BTT move to ideal range. And as always, search for event execute, receive execute AI, and finish execute. And now we want to get the attack target again. Now, one thing we did in our, where is it? In our decorator is that we just got the attack target from our AI controller. We can also pass in the attack target as a blackboard key if we want. But here I'm assuming that we always know who the attack target is. Maybe it's actually a better idea to pass it as a key. That way it's more extendable, this function. So let's do that. I'm going to duplicate this, call this our attack target. And instead of getting it like this, I'm going to be getting the attack target and say get value as actor. And then that's our attack target. That's just a tiny bit cleaner because now the task doesn't know anything about the AI controller that's controlling it. And it avoids casting, which I usually prefer. All right. And of course, in our behavior tree, we have to pass our... Oh, did I not compile? I did not compile. And in our behavior tree, just pass in the attack target, which, yeah, already was selected. And we're going to do the same in our move to ideal range. Create two keys. The first one is going to be our ideal range of type blackboard key selector. Always remember to click the eye icon. Duplicate and call this attack target. And for good practice, I forgot to do this as well. Add it in a category called keys. I will do it with our decorator as well. Keys, whoop, misspelled keys, and keys. All right. So our move to is going to be very simple. It's just going to call AI move to on our controlled pawn. And it will finish execute on both success and fail with success true. And the target actor is going to be our attack target. Oh, this is called still Kets. Why can't I spell keys today? Okay, so our attack target Ket value as actor. And this will be our target actor. And our acceptance radius, that will be our ideal range. So ideal range, get value as float, and that will be our acceptance radius. Nice, and that's basically our custom move to ideal range task. It's quite simple. Compile and save. Back in our behavior tree, how do we call this? We just say move to ideal range, pass in the defend radius because this is in the strafe task. And pass in the attack target. And probably before you move to the ideal range, you want to run to it. So let's set the movement speed to sprinting. Move all of this a bit to the left here. I just have to clean this up. Things are getting out of control. All right. So we want to set the movement speed and move to the ideal range. And probably you want to clear focus first in case you're focusing on something. And then in our strafe sequence, we set the focus at target, set our movement speed, and then start strafing as usual. And over here in our attack target, I'm also going to delete this move to target and replace it with our custom move to ideal range. And the ideal range will be our attack radius, and our attack target will be our attack target. All right, so now if we are within the strafe branch and we're not in the ideal range, we'll move to the ideal range first. And if we are, then we're going to start strafing. So let's test this out. All right, so I'm not within the ideal range, so the enemy runs at me. We're within the ideal range now, so the enemy starts strafing. Excellent. And before attacking, they should move within 150 and then go back to strafing. Excellent. So if I run away from the enemy now, they don't, well, now they're yeah, okay. Let me show you again. If I run away from the enemy now, they will always chase me to get within the ideal range. Except in one condition, if they're between moving. So right now, the enemy is moving to another point. They'll wait until they reach that point and then run. But we want, when we get out of range, to interrupt whatever they're doing and chase the player instead of finishing what you're currently doing, which is moving to the next point. So he waits to move to the next point and then starts chasing. We don't want that. So that means that we want this decorator to abort lower priority. Means that as soon as this value, as soon as this condition becomes false, or actually becomes true, then abort anything of lower priority, which is everything on the right. So let's test this out again. Let's play. So we're gonna go within the range, they're strafing, they're between points, I run away, they don't wait. So again, they're between points. As soon as I get out of range, they start chasing me. Final test, strafing, run away, they stop what they're doing to chase me. Excellent. Now the enemy seems a lot more aggressive and more responsive to the player's actions. So that's pretty much it for our strafe functionality. But I want to show you one additional thing for this tutorial that you can do with the EQS. So I want to create an enemy that's an EQS template that gets the enemy to hide behind cover and then come out of cover to attack and then go again behind cover. So for example, let me, I don't know, take this wall here, duplicate it, make it a bit thinner. Yeah, something like that, and taller. All right, let me move, let me delete this. So what I want now is for the enemy to hide behind this wall and then after a few seconds come out to attack me, just to show you how you can use the EQS system to create enemies that take cover. So jumping back to our EQS folder, let's right click and create a new environment query and call this EQS underscore find cover. All right, so let me close everything here to decrease the clutter. Yeah, let's close these two as well. And I just need my context for testing. And I'm going to add in our testing player start and move our find cover here next to our level. All right, so back here with our testing pawn. And before I forget, the testing pawn is still using the environment query. So if you search for EQS, it's still using the Strafe EQS. So we're going to replace it with our find cover. And now we can start testing this out. So how do we get the enemy to look for cover? Well, I want the enemy to search for anywhere that the player can't see them in a grid. So we're going to generate a grid of points. So off of root, search for grid. And I want the enemy to look for cover within, let's say, 1,000, well, 2,000 because it's a half size. So an area of 2,000 around them. And let's say the space between each point is like 200 or yeah, maybe 150, something like that. And the first test we're going to add, as always, is our path finding. So we want to make sure that it's a reachable location. And the second point is we want to make sure that it's a location where the player doesn't see the enemy. So to do that, we're going to add a trace test. So we're going to do a filter and score. And on trace data here, we're just going to do a trace on the visibility channel. We're going to do a line trace. And the trace is from our querier. But who is it to? What's the context that we're tracing to? Which is, if you search here, other end of the trace test. And that's going to be our attack target. So if I search that, you can immediately see that everything that's blue is somewhere where the player can see me, and everything that's green is somewhere where the player cannot. But you can see that also here, these are green. And the reason why these are green, even though the player can clearly see from this point, is because the line trace is actually hitting the slope itself. So we want to tell the line trace to start from the height of the enemy's maybe eyes or body, but not from the feet. So to do that, there is a item offset and context offset. So let's add maybe to our context height offset something like 100, and to our item offset also 100. And then this will remove all the points that we're currently colliding with the slope. And by the way, if, for example, I decrease the height of this wall, these points are all still green. But if I increase the item height offset to something like, well, to be higher than the height of the wall, so maybe like 600, these points are no longer green, because I'm telling it that the item that we're tracing to can see up to 600 units up in the z-axis. So obviously they can see over this wall. But now I'm just going to set it to 100 or whatever. You can use this to be the height of your character. So maybe even 180 would be nice. All right. And I don't think actually we need the context height offset. I don't think this is going to do anything. Let me just remove it to 0. Yeah. So it's only the item height offset we need to be using. Great. But now all of these points are equally as likely for the enemy to move to than the other. I want actually the enemy to choose the closest point to them and not just any random point. So we're going to add a new test and distance. Right, so click on our distance test. And for this one, I don't want to filter anything. I just want to add a score. So I'm just going to say score only. And right now, you'll see that over here it says prefer greater. And the points that are further away have a higher score. I actually want it to prefer lesser, means that the points that are further away should have a lower score. So to do that, we change the scoring equation from linear to inverse linear, which just means inverse however you're doing scoring. And now this says prefer lesser, and the points that are closer to the enemy have a higher score than the points that are further away from the enemy. Great, so let's open up our behavior tree again and start running this task. Now I'm just going to move all of this away from here, and I'm going to create just a new sequence for testing purposes, and this will be our call it find cover sequence. So before the enemy finds cover, they should clear focus. They should set movement speed to running or sprinting. And then they should run the EQS, which is our FindCover EQS. And I want the run mode this time to be single best, because I wanted to pick the single best item. And the Blackboard key will be our point of interest that will store the vector. And we're just going to do a move to point of interest with maybe a 10 acceptable radius. All right, so right now the enemy should find cover and then move to it, and just keep repeating. So let's test this out. Oh, and of course, plug this back here. Let's move also our testing pawn out of the way. All right, so enemy should see me, start to attack, and then say, hey, no, I don't want this. I'm gonna go hide. Great. So if I go and to a point where the enemy can see me, they're gonna run away. They're gonna be like, nope, no, no, they can see me. I'm gonna run again. So now I'm playing hide and seek with the enemy. So let's give them some more behavior. Let's say the enemy finds cover, waits for a few seconds, let's say maybe 2 or 3 seconds, and then comes out to attack. So waits for a few seconds and then moves to the attack radius. Yep. And this is our attack target, and then calls the default attack function. Nice, let's test this out. Enemy sees me, runs away, hides, waits a few seconds, comes out, attacks me, and then runs away to hide again. Excellent. All right, so that was a brief introduction to the environment query system. And so far in the past 3 tutorials, we've covered behavior trees, how to create custom tasks, custom decorators, how to use the AI controller to run all of these and set values in the blackboard. We've covered the perception system, and we've created different states for our enemy. But so far, everything we've been doing has been in the base enemy class, and we haven't covered different types of enemies. So in the next tutorial, we'll be creating child enemies out of our base enemy class. So we'd have a melee enemy, a ranged enemy, maybe you have a defensive melee enemy, an aggressive one, and so on. So we're going to see how we can inherit from the functionality that we've been creating so far to make a wide variety of enemies with different behavior trees and different tasks in general. So I hope you enjoy it and see you there.